Today we're going to look at piecewise functions, and a piecewise function is a type of function that is defined by different formulas or functions for each given interval in the domain. It's also in the name piece. The function is defined by pieces of functions for each part of the domain, as I just said. Look at those graphs below. Those are piecewise functions where you've got pieces of different functions. Number one, evaluate each function graphically. So let's look at what's going on here. In number one, it looks like we had some kind of parabola, and then we have a linear function, but those are, again, shortened or defined by the domain, and we'll look at some more examples here in a moment. For number one, down here, we have f of 6 equals what? And so to evaluate a piecewise function, just remember, usually we see f of x. So let's evaluate where x is equal to 6. On my x-axis, going to 6, travel and meet our graph, and we're going to say where it was on the y-axis at 5. So f of 6 for this piecewise function, when x is 6, the y value is 5. That's how you evaluate this piecewise graphically. Number two, we had a horizontal line starting off, maybe a linear function, and then another parabola. And we are evaluating for where f of -3, or where x is equal to -3, going on my x-axis to -3, traveling and meeting my graph, that y value is -3. Looking now at number 3, this one is very unique, right? We do have these open circles on our piecewise functions. So when there's a gap there, there is another point defined just above that. So let's see what we're evaluating here on number 3, where x is -3. X-axis going to -3, that exact place we were just looking at. So there's a hole or an open circle on the parabola graph. It is filled in, and the function does exist when the y value is 2. Number 4 had another horizontal line, open circle at the intersection. But look down here. Do you see this one? There's a point down here. And then there was a linear function with a negative slope. Let's evaluate for where x is equal to 0 on my x-axis. 0 would be right there. If I travel up, we have that open circle. The function does not exist there. If I travel down, I get to that solid circle, and its y value is -6. So that's how you evaluate piecewise functions graphically. Do take note, those open and closed circles would be where those functions exist or do not exist. The next section of our Delta Math assignment is going to be for you to graph piecewise functions. So this is what they look like. You have f of x equals, and it usually has a bracket, and it branches off to these different segments or different pieces. And notice we are defining 4 specific values of the domain. So on Delta Math, this is, of course, a little bit easier. They're going to give you an option of the shape that you want to graph of the parent function. So let's start off with the top one. I'm going to highlight that one that we're going to start with, just looking at that piece for now, okay? And let's do it in green. F of x equals the top one, x minus 2, and let's just start there. X minus 2. What parent function is that? Just plain old x. Plain old x is just a linear function, a line. So on Delta Math, they have those different shapes prepared for you, and you just choose, I need a line. Notice I did sketch a positive slope. We've got some other examples coming up. Positive slope going up from left to right, linear function. So when I get that graphed, on Delta Math, it's going to put it right at the origin. But what do we know? We know that -2 at the end does what? Pulls it down 2 units. So I'm going to make some notes here for you. So I'm going to erase my sketch, and we're actually going to be going through -2, and I'm going to get a really good graph here. Again, on Delta Math, it's going to populate most of that for you, but I want to have a nice, good example for you. I'm going to go ahead and graph the whole thing. The next thing on Delta Math is going to show you, after you hit, I think it's next, there's a button that you have to click to go to the next part. It's going to ask you to define that domain. So we're looking at all the values of x that are less than or equal to -3. So all of the area that is less than or equal to -3. So this side of the graph, I'm good. Leave it over there to continue to expanding to infinity. This side of the graph, I'm going to pull it in so that it will restrict my function to only that far. So we're going to erase most of this so that we only have from -3 any x value less than or equal to -3. Notice I put that solid circle there. Let me erase some of my other notes here so you can see what that final product is going to look like. Okay, on delta math, I'm going to hit a linear function. I did have a positive slope. I'll drag I think they're blue dashed lines so that it defines this domain, all the x values that are less than or equal to -3. Do keeping in mind solid or open circles here. It was less than or equal, so I used a solid circle. Let's look at the next one. Below that, we have this square root of x plus 3, and the plus 3 is inside for the domain where x is greater than -3. So you'll choose your parent graph for a square root. It looks like the shooting star. It would look something like that, parent graph. But we know plus 3 inside is going to move us left 3 units. So I'm going to shift that over. So it's shooting like so. And then we are graphing anywhere that is greater than or equal to -3. So I would take my left dashed line, pull it in so that it is over that -3. And I will make sure I have an open circle on -3. But everything else should be able to stay. It will be graphing, as long as it's got an open circle, it'll be graphing all the values that are greater than -3 on that square root function. And I'm done for that one. Let's look at number 6. F of x equals x squared minus 1 for that top function, x squared minus 1 here, for all the values of x that are less than 3. All right, so parent function, a parabola. So on delta math, I'll choose that parabola shape to get me started. And I know that it has been shifted down 1. So graphing our parabola would look something like so. 1, 2, 3, 4, 5. Sorry, I want to get some good points here. And we'll study, we'll review graphing parabolas. All the values that are less than 3. Here's 3. I want all the values that are less or to the left of it. And we do have an open circle. So I did have a point that I was starting to graph for my parabola. So I'll make sure to have an open circle there on that +3. And so I've just finished graphing my parabola through the domain only where x's are less than 3. For the bottom part of this piecewise function, we have f of x equals -x minus 2. What's the parent function? It's a linear function, but we have that negative in front. So you know this from like 8th grade math and algebra 1, that this slope is negative. So let me switch my little doodle there. We should choose a downward sloping, down from left to right, linear function. And it's also going to be shifted down 2 on the y-axis. So we're going to be living down on -2, a negative slope like so, only where x is greater than 5. So over here, here's 5. And I'm going to need open circles. So let me regraph this with an open circle, and then my linear function would continue. And so that's the final product for number 6. We had the quadratic x squared minus 1 only where x is less than 3. We had an open circle at 3 for the purple parabola that was shifted down 1. See that? And then in pink, -x minus 2, a negative slope. It was shifted down 2. But only where x is greater than 5. We had an open circle on 5. Paying attention, I think that's where it's going to get us, paying attention to our inequality symbols when they are strictly less than or strictly greater than. Make sure you have an open circle there. Number 7, the top one, of course, I grabbed this for our notes to make sure you saw this. F of x equals -3. Anytime we have like y equals just a number, no variable, it always creates a horizontal line, and you do have that option on Delta Math to choose a horizontal line. I forget where it defaults to, but notice our number is -3. So you would want to pull this down or make sure it's in line with the y value. -3 would be correct. We are looking for only where our x value is less than or equal to -3. So look in here, I would have solid circle and everything left of that. So let me regraph that like so. So f of x equals -3. If you just have a number, that's a horizontal line at that value on the y-axis, and then paying attention to your defined domain, all the values that are less than or equal, solid circle, from -3 to the left. Below that, we have f of x equals, second piece here, absolute value of x minus 4. Parent function is that v, but what's happened? It's moved to the right. Remember, when it's inside, it goes opposite of what we would expect. So I'm thinking over here at +4, I have a nice, beautiful v for my absolute value. Our defined domain is from 0 to 9. And notice they are inclusive. They have those equal pieces. So I'm going to have a solid circle to start at where x is 0 and solid circle to end at 9. So let's see, somewhere probably here. Let me regraph that because I went out too far on that left side. Like so. So there's our final product. We had f of x equals -3 with that horizontal piece, but only graphed from where x is -3 and less to the left. And then we had the absolute value of x minus 4. So it got shifted to the right 4 places, a V shape from 0, solid circle, to 9, solid circle. Those are your 2 pieces for your piecewise function. Number 8, and our final example for our piecewise functions, we have f of x equals x. I thought this one looked a little unique, might kind of make you wonder, that's just a plain old linear function. It's got a understood +1 slope, an understood 0 y-intercept. This is the parent of parent linear function. So it would literally be right through the origin, a 1 slope. And our domain here is from -4 open circle to 3 open circle. So -4 open circle, 3 open circle. Something like that. The bottom part of our piecewise function, the quantity of x minus 5 squared minus 3. So that squared tells us the parent shape is the parabola. We are moving to the right 5 places because it's inside, left and right, but backwards, and then we're down 3 units. All right, let's see if I can do this. So instead of the origin, I need to be right 5 and down 3. So I'm living somewhere here with my parabola. All right, but we only are living from 4, +4 open circle. So this point that I graphed would be open and 7 is closed. So actually just a little piece of this parabola. Let me erase all these others and we're right here. All right, let me grab one on Delta Math and show you how it works, okay? So here is that same problem on Delta Math that we just completed as our last example on our notes, the top being f of x equals x, plain old parent, positive slope, linear function. So I'm going to click this second to last one to give me that positive slope right through the origin, no transformations here. So I'm going to click done. If I needed to shift it for a transformation, I would do that before clicking done. Now I'm going to drag those blue arrows to set my domain. It was from -4 to 3, both open circles. So I'm going to drag over to -4 and click to make an open circle. Drag to 3 and click to make an open circle. And check and make sure I got that all good. All right, done. Now let's do the second function. So the second one gave us that parabola shape. It had transformation. So we went to the right 5 units and down 3. When I've got it placed, I'm going to hit done so I can do my domain from 4, again, open circle, and to 7. and it was closed circle. I think I may have typed it differently on our notes, but I've finished fixing that and I am done. Now, I have accidentally many times hit start over. Guess what you do when you hit start over? You have to start completely over. So try not to hit that. If you do need to start over, it's there for you. Instead, hit submit. And that's our notes and our examples for piecewise functions. Evaluating them graphically, we're looking at the x values, we're telling what the y value is, reading these graphs graphically, and then the second part, we are graphing them. Be mindful of your open and closed circles there. And guys, let me know if you have any questions, and I'll see you in class.